So last class we did we did expanding. Let's have a look. I want you to expand y is equal to x plus 3, x plus 3. From yesterday, we used FOIL. First, this is going to be x squared. Outside plus 3x inside, and then, inside and then last. So we get this. And then we can simplify this. Then this is x squared plus 6x plus 9. What perfect squares means is the roots are the same. Perfect squares. What does perfect squares mean? This equation here has a perfect square. Perfect squares means that the roots are the same. And we already had the example there. If the roots are the same, for example, x plus 3, it can be simplified is x plus 3 squared. So if you see an equation with the squared, you can actually expand that polynomial out by writing the 2 bracket. And then you can do the operation FOIL here, and you will get this equation when it's expanded. Okay, so that's the topic. Now, if I were to represent a perfect square, why do you think we call it perfect square? Well, we learned that another way to expand a polynomial is by modeling that with a graph, where we have the length and the width. So if I were to do x plus 3 squared, on one of the lengths is x, here. And then I have 3. I have 1, 2, 3. So if I wanted to model this expanded polynomial, that would be the area inside. Well, in here we're going to have x times x. It's going to be this. And then I'm going to have these kind of widths here. This x times each of these individual guys. Then I'm going to have this right here. And then these little dots. I'm going to have a whole bunch of little dots right here. 1 times 1. So I can represent this looking something like this. What a perfect square, what does it mean? If you look at this, it actually creates a perfect square. So perfect square, the length and the width are the same. This is a perfect square. And you know, we like perfect squares. The reason why we like perfect squares because there's a form of quadratic equation. If they're perfect squares, they can simplify down into 2 factors. Like this big guy here can simplify down into this guy right here. And that looks very similar to an equation we learned. If you recall, the vertex equation is y is equal to a x plus or minus h squared plus or minus c. Right here, in vertex form, you'll notice, what do you notice here is we have a perfect square. We have a perfect square right in the vertex form. Perfect. So therefore, if we can find perfect squares, we can actually change my equation into vertex form. So how can I do that? How to determine vertex equation. To determine the vertex equation, what we can do, there's a procedure is called completing the square. Completing the square will enable us to get this form, okay? So let's have a try here. Here's an example. If I have y is equal to x squared minus 6x minus 2. Okay? This equation is not in a perfect square. This is in standard form. This is called standard form. Well, I want to get into vertex form. How can I go from standard form into vertex form? We can do that by doing this operation called completing the square. And the procedure is we have A, B, C. Okay? In standard form, we have the coefficient, the number here is called A. In this case, we have 1. In this case, it's minus 6. In this case, it's minus 2. So the steps. Step number 1. You're going to take your middle term and divide it by 2. Okay? Take your middle term and divide it by 2. So in this case, we have 6 is B divided by 2. We're going to get equal to 3. That's step 1. Completing the square. Step 2. You're going to square the results. B over 2 squared. B over 2 squared. Well, that's going to be the same as 3 squared. We're going to get 9. Step 3. We're going to be converting this into a perfect square. Is you're going to add term after middle term and subtract at the last term. This guy's the middle term and this C is the last term here. So my equation is y is equal to x squared minus 6x. I'm going to put add something there, minus 2, and then subtract something here. We take our original equation, and this is the key number that we want. This is the key number, and we're going to add them here, and we're going to subtract them here. Okay? Now, after we do this procedure, this and this will become a perfect square. This is a perfect square. And the perfect square will be equal to this number here. Okay? So my last equation will be, and we're going to talk about this later in the future, but this is going to become x minus 3 squared, and then we just have to simplify this. We have minus 11. There we go. So if we do that, we have now the vertex form. This equation, from standard form, we can get into vertex form, and now I can know my vertex. My vertex is going to be equal to, the x value is going to be 3, and the y value is going to be negative 11. Very useful. Okay, there's 3 steps. You take the middle term, divide by 2, you square it, then you're going to add it after the middle term and subtract it from the last term. The first 3 guys are going to reduce into a perfect square, and we can write it there. And that leads us to a couple of equations. If I need to expand, we have this thing called sums and difference of squared. So if I have a plus b squared, if I were to expand this, we also have an equation that's going to be equal to a squared minus 2ab plus b squared. This is the, and then the difference, a minus b squared, is going to be equal to well, I think I wrote that down wrong, guys. If it's plus, this is going to be a plus. And then if it's minus, it's going to be a squared minus 2ab plus b squared. Okay? Again, we're talking about squares. So 5 squares, one thing is I can make a perfect square from standard form. And also, if I wanted to expand, I can use this equation. Let's do a quick example. Right here, I have y is equal to, we'll do the same one here. It's x plus 3 squared. If I wanted to expand it, one way is to do this, but this way takes too long. I can apply this equation here. It's going to be equal to a squared. So this is a, so it's going to be x squared plus 2 times a times b. A times b is 3x. Because this is your a and your b, plus b squared. B is 3, that's 9. If I'm using that law, you'll see that I get the same answers here. Okay, I get the same answers here using this property here. Again, these are called the sum and difference. These are basically, this is the sum, and this is the difference of perfect squares. Perfect squares. This means that they are square.